Okay, so we're given that the derivative of f of x is equal to 3x plus 2, and given that f of 2 is equal to find f of x. So I'm going to use, firstly, the integration method to show you how it's done. So firstly, we know that the derivative, I'm just going to write everything out so it's easier for me, is equal to 3x squared plus 2. Now, when we integrate this, we get, so we raise the power by 1, then divide it by divide the coefficient by it, so we get x cubed for the first term. When we have a constant, add the x, so we get 2x plus c, because we have a constant to add. Now, if we, so this is equal to f of x, so if we have f of 2, we get 2 cubed plus 2 times 2 plus c, which is equal to 8 plus 12 plus c, which is equal, 8 plus 4 plus c, which is equal to 12 plus c. And we know that this is also equal to 5. So c is equal to 5 minus 12, which is negative 7. Therefore, our function is x cubed plus 2x minus 7. Now, I'm going to actually show you how to do it without using integration, because in some cases, maybe you're studying for the internal exams or something, and you haven't learned how to integrate yet. So the way you would do this is, first you would think about how you differentiate. So when you have a function, let's say x cubed plus 4, the way you differentiate is, A, the constant goes away because it has no x value in it, and then B, you have x cubed, you drag the power down and lower the power by 1, so you get 3x squared. So a similar process occurs here, but the only thing we need to think about is that when we have x cubed, we have a cubic that goes down to a quadratic because we're decreasing the power by 1. So in this case, if we look at the highest power, which is 3x squared, that means that the highest power of our original function has to be 1 higher, because in differentiation, you decrease that power to get our derivative function over here. So I'm just going to write down the general formula of a cubic because we have a quadratic for our derivative, so that means the cubic must be the regular function. So f of x is going to equal, and the general cubic function is ax cubed plus bx squared plus cx plus d, which are constants that we have yet to figure out. Now I'm going to differentiate our general cubic formula, which becomes the derivative of f of x is equal to 3ax squared plus 2bx plus c, and the constant goes away. Now, what we have to do is compare it to our derivative function that we already know is 3x squared plus 2. If we compare like terms, we can obtain a, b, and c. So firstly, let's take a look at, I'm just going to switch back to red. The coefficient of x squared on the right is 3. On the left, it's 3a. So 3a has to equal 3. Hence, a is equal to 3 over 3, which is just 1. Now, we also have, on the left side, we have 2b is the coefficient of x, but we don't have a coefficient on the right side. That means we can assume the right side has a coefficient of x of 0. So 2b is equal to 0, so b must equal 0. Now at c, this is relatively easy. The constant here just matches the constant on the other side, so c is equal to 2. Therefore, we know that the original function, which we said is ax cubed plus bx squared plus cx plus d, has to equal x cubed plus 0x squared, so just, it's not there, plus 2x plus d. Just substituting our values of a, b, and c in there. We don't have d, because d went away when we differentiated this function over here. Okay, so we're going to use the last piece of information in order to solve this problem. So f of 2 is equal to 2 cubed plus 2 times 2 plus d, which is equal to 5, according to the information we're given. So 8 plus 4 plus d is equal to 5. I'm just going to make this an imply sign. So 12 plus d is equal to 5. D is equal to negative 7, since it's 5 minus 12. Therefore, as we got in the previous way we solved this problem, f of x is equal to x cubed plus 2x minus 7.